Hello everyone. In this video, I'll walk you through the containerized data importer, or CDI, in Harvester, and explain how CDI settings work with storage classes. CDI is a Kubernetes project designed to turn PVCs into usable VM disks. In Harvester, CDI is used to handle VM image operations such as downloading image from an HTTP URL, uploading images from a local disk, and cloning existing PVCs to create new VM images. In short, Harvester relies on CDI as the module for managing VM images. Currently, CDI works with three types of storage classes: Longhorn v2 data engine, LVM, and third-party storage. It's important to know that CDI is not used with Longhorn v1 data engine, and you can configure CDI either through the Harvester UI or by adding annotations directly to a storage class. Each field you see in the below CDI settings screenshot maps directly to a storage class annotation. At the moment, we support 4 kinds of CDI annotations. These can be configured when you create or update a storage class, and let me explain each of them. The first one is volume mode and access mode. This defines the default PVC volume mode and access mode that will hold the VM image. For example, you might set it to block mode with rewrite many access. The second one is the volume snapshot class. The setting is only applied if you choose the snapshot clone strategy. Behind the scenes, CDI will create a new PVC from snapshot, which makes cloning faster and more efficient. If you already configured a volume snapshot class name in a CSI driver config for your provisioner, that value will be used as the default value. The third one is clone strategy. This defines how volumes are cloned from VM images. There are 3 options: copy, which simply copies the data over the network; snapshot, which creates a temporary snapshot and restoring it into a new PVC; and CSI clone, which use the CSI driver's native clone operation. Snapshot and CSI clone are only available if your CSI plugin supports those features. Finally, the fourth annotation is the file system overhead. This is the percentage of file system overhead that CDI should consider when calculating PVC size. For example, a value of 0.05 means 5% overhead. So before we move on the demo, there is one important note. CDI with third-party storage is not yet supported in the UI. This means you can only configure CDI through the UI for LVM and Longhorn v2 data engine. If you want to set up a third-party storage class, you will need to apply the annotations manually using kubectl. So now let's take a quick example using Longhorn v2 data engine. Suppose we want to configure the following: set the volume mode to block, and the access mode to rewrite many, and set the volume snapshot class to Longhorn snapshot. Use copy as clone strategy, and define the file system overhead to 0.05. When you click the Edit as YAML, these settings will appear as CDI annotations in the YAML definition. And after saving, you will also see that these values are reflected in the storage profile and the CDI objects. Here, you can see the CDI objects stores the file system overhead, the Longhorn v2 0.05 here, and the remaining settings are stored in storage profile. As you can see, there are 3 settings here. Okay, so what is a storage profile here? It's basically a Kubernetes object that acts as an abstraction layer on top of PVCs, holding a set of default values. And each storage class has a one-to-one mapping with a storage profile. When you create a storage class, the storage profile is automatically created. And while most settings go into the storage profile, the file system overhead is applied directly to the CDI objects. And the CDI objects is the global configuration object for the CDI itself. Okay, so to wrap up, the CDI is the component that makes VM image import, conversion, and cloning reliable in Harvester. And the Harvester annotation gives you a straightforward way to control how these operations works across storage classes and storage profiles. That's an overview of CDI and CDI settings in Harvester. Thanks for watching.